All right, so our next set of notes, now we're gonna combine that idea of moles to moles and mass to mass, but what we're gonna do is I call it moles to mass. And we're going from moles of one thing to mass of another thing, or we're going mass of one thing to moles of another thing. All right, now one thing in which I always like to point out in this is that we end up with multiple variables. And one thing, if I were to give you a mathematical equation where you had this, now what I want you to do is I want you to solve that. Y equals x plus 2. Can you? No, you can't, can you, right? Because there's two variables. You have y and you have x. So because you have both of those, then you can't solve this problem. You need to have another equation in order to solve it. If I were to give you another equation where x equals 1, could you now solve it? Yes, because now you can take the 1, put it in here, and then you go 1 plus 2, and now you know y is 3, so now you know y is 3 and x is 1, and you'd have both answers. But it takes you two equations in order to solve this because you have two variables. Right? Now, why in the world am I doing this? Because you're like, wait, this is a math class, this is chemistry class. Well, remember that this chemistry is actually math. What's going to happen now is we're going to have more than one variable that we have to solve for. So now the other thing I also wanted to point out was I gave you this, which is the cheat sheet, stoichiometry cheat sheet. And you got up here at the top, there's moles to moles. And it says, use the balanced equation, then set up the ratio for the balanced equation numbers, and then solve it. And then you have mass to mass, and it gives you some shorthand idea of use the balanced equation, calculate the molar mass of the compound, set up the ratio using the molar masses, and then solve it. So the idea behind this was to try and help you. The top two, those are the ones we've done so far. And so try and give you like some little shorthand ways to help you remember how to do them. Now what we're going to do is we're going to go down here to this one where it says moles to mass, right? And notice it says above it, it says that these we use to switch the units of a substance, right? So we can only use this one down here to change the units of one substance into a different units for that same substance. The ones up the top, these two, these are the only things that allow me to go from one thing in a balanced equation to something else. It lets me get from one side to the other, or from this guy to this guy. Right? I can't use any of the ones at the bottom to get from one thing to another. I can only use it to change the units of one thing to the units of another thing of that same substance. Now, as we go through this, hopefully what I just described will make some more sense. All right, so let's look at the notes. First one there, it says, you got this equation that I wrote on the board. It says, how many moles of NaOH? So we have how many moles of NaOH? So we need X moles of this guy. If we got 54 grams of water, 54 grams of this guy. All right, so now this is where I'm talking about the multiple variables. We have two different variables. One variable is we're talking water, and we're talking NaOH. The second variable is we're talking grams, and we're talking moles. Right? So I can't do this in one step. It's going to take more than one step because I have to change the units of this thing into something that relates to this unit so that I can get from one to the other. Right? That's going to be one of my options that I can do. So if I'm going to do that, then what I got to do is I can utilize, let's see, I'll make sure my notes are the same. What I did in the notes was we're going to go grams of this to get to grams of that. So we're going to initially try and find grams of this guy. I know that's not what they asked for because they asked for moles, but then we're going to be able to change those grams into moles. So in order to do that, I'm going grams to grams. So that means, according to that cheat sheet, I need the molar masses. So I need the molar mass of this, where it's 2 times 1 for hydrogen, plus 1 times 16 for the oxygen. All that times the big 2 that's out in front. So that is 36 grams of this guy. Then if we go over to this one, it's 1 sodium, which is 23, plus 1 oxygen, which is 16, and 1 hydrogen, which is 1. All of that times 4, which happens to be 160. So now we can set up the ratio of 36 grams of H2O will make 160 grams of NaOH. And then we go to our question. Well, I don't have 36 grams. I got 54 grams of water. Now I know X grams of NaOH. So solve this, go 36 times X. equals 160 times 54. Divide both sides by 36. And X ends up equaling, turns out to be 240 grams. And that's of NaOH. So we now know that this one up here equals 240 grams of that. All right. So we have now found out that 54 grams of this will make 240 grams of this guy. All right. So now I'm done with this. All right, because I've changed that. So now I'm going to take this 240 grams of this and change it into moles. In order to do that, I have to use, according to my cheat sheet, I got to use moles to moles. I'm sorry. What does it get? Moles to grams. Make sure I set it in the right direction. So we got to go moles and grams. We got to change these. And it says in the cheat sheet, says use the molar mass of the substance. So here's my molar mass. That there is 160 grams of NaOH. And that's actually per the number that's out in front, which is 4 moles of NaOH. Now notice at this point now I'm using NaOH only, right? But my difference is grams and moles. This is where I only have one variable. Over on this one, I had grams and grams, those were the same. But my variable was water and NaOH. Right? So that's what I mean by this idea we got to do multiple problems on this. All right, so now I go, well, I don't have 160, I got 240 grams of NaOH. That's what we found out. And we're going to change that into X moles of NaOH. Cross multiply 160 times X equals 4 times 240. Divide by 160, divide by 160. And X ends up giving an answer of, oh, I got to switch my page because gives me an answer of 6 moles of NaOH. Is that what they were asking for? Yep, they want to know X moles of NaOH. So good, so all right, so we got that then. All right. So again, what I said, this takes multiple steps. It took us 2 steps. We had to do this, and then we had to do that step. All right, I can't do it in one step like we were doing on all the stuff that we've done up till now. All right, so let's go to another example. Let me erase all this. Because now we're going to have a different recipe. We got a different balanced equation. All right, so this balanced equation is 2AgNO3 plus H2S forms Ag2S plus 2HNO3. Okay. All right. The question says, how many grams of HNO3? We want to know X grams of this guy. Okay. Will be formed from 3.7 moles of H2S. So we have how many? 3.7. So 3.7 moles of that. We want to find X grams of that. All right, so again, we can't do it in one step because I've got a different unit here and I got different substances. So this means this is going to take more than one step. All right, so our first step, we're going to change moles of this into moles of that. Because according to my cheat sheet, I can either go grams to grams or moles to moles to get from one substance to another, right? And you're always going to start with the one that's got a number. Well, here's the one that's got a number, so I'm starting with that one. Notice it's got moles, so let's go moles to moles. So we're going to put up here, we're going to find X moles of this thing first. So to do that, I need to set up my ratio from the balanced equation, where it's 1 mole of H2S will combine to make 2 moles of HNO3. That comes from the balanced equation. Well, then I really have 3.7 moles of H2S, not H2O, make that H2S. And we want to find out X moles of HNO3. All right, cross multiply, 1 times X equals 2 times 3.7. So X ends up equaling 7.4. And that's moles of HNO3. So we now know that this is 7.4 moles. Now I gotta change moles of this into grams of this. According to my cheat sheet down at the bottom, So on this thing down here at the bottom, I've got moles to grams, and it says I need to use the molar mass of that substance. So I gotta use the molar mass of this stuff. So it's 1 times 1 for hydrogen, plus 1 times 14 for the nitrogen, plus 3 times 16 for the oxygen, all of that times 2. All right, and if you multiply that all out, you get 126 grams. So I am going to take 126 grams of HNO3 per the number that's out in front, which is 2 moles of HNO3, equals, I don't have 2 moles, I have 7.4. We're going to find x grams. So cross multiply, 2 times x goes 126 times 7.4. Divide by 2, divide by 2. X ends up giving me an answer of 466 grams of HNO3. Now, is that what they wanted? Yep, they wanted grams of it. That's what we found was grams. Sign up with grams. All right. So now, no, these ones take a little bit more work. And again, the concept behind this is look at the idea that we are talking 2 different substances and 2 different units, right? I'm going from moles to grams, and this stuff's that stuff. So therefore, this takes more than 1 step, right? And you can utilize this cheat sheet that's on there. You can print it off, and hopefully it can help guide you. Remember the top 2, those only allow us to get from one substance to another substance. Bottom ones, and currently we've just used the first one, allows me to change the units. Where this stuff over here, I changed it from moles to grams of the same substance, right? Next set of notes later on, we're going to learn these other 2. And we're going to add those in to change units. But again, I hope you notice that nothing on here is anything new to us, really. It's all the same stuff we've been doing. It's still moles, grams, volume, number of particles. It's all the same thing, but now it's all about math of each thing, right? Pretty complicated, I agree. Keep trying and you can do it. We'll talk to you later. See ya.